So thanks for organizing this great workshop. Thanks for having me be part of it. I'm going to present a joint work with Rob Garlick at Duke, and this is very preliminary work in progress research, as you will see. So a lot of comments, suggestions are most welcome. Let me figure out how this works. Okay. So, oh, thank you. So as we all know, there is an inherent tension when we're modeling things between modeling things, so having a theory, and then capturing the underlying heterogeneity. We know that individuals behave differently, and typically whenever we estimate structural parameters, these are just mean parameters that indeed hides a potentially large amount of heterogeneity. So on one hand, one way to think about our project is that this is sort of a cautionary note into trying and separate out, show that mean impact hides heterogeneity. We look at it within the context of the collective rationality model, as I will go through in a couple of slides. And one of the sort of premises of this model is that there are a number of experimental papers that use very small samples that show that there's a large degree of heterogeneity across households. In particular, for example, I'm sure most of you are familiar with the Ashraf 2009 paper in which she was varying the amount of information that was private to spouses, showing that that affects the behavior of some households but not others. More recently, Shaner also showed that, as has been commented yesterday, that spouses with different preferences behave differently, and that has implication for the efficient allocation of resources. There's also another recent paper that I forgot to cite by Jess Hall, in which, again, she varies the degree of information that is private and public and shows that some households' behavior is strongly affected by it, but not all of them. Okay, so we have, and there's a larger literature in the background that I didn't cite. For example, Ashraf, Field, and Dee that show that, again, the importance of private information in affecting households' behavior vis-a-vis fertility and contraceptive choices. So basically, we have evidence, and it's not surprising that households behave differently, especially that their behavior vis-a-vis efficient allocation of resources might vary cross-sectionally. Yet at the same time, whenever, or at least a lot of the evidence that I'm aware of large-scale samples shows evidence that is consistent with collective rationality. Okay, so there's a bit of sort of tension between this evidence from these small-scale experiments and evidence from large observational data. Of course, there are exceptions. We're all aware of them. So I will just mention them in passing. So there's differences with collective rationality being more likely to be rejected from African countries. Think about Duflo and Udry and other work, or from looking at production versus consumption. Okay, what we do in this paper is three things. So first, we show that in a very homogeneous setting, so central rural Mexico among poor households, we find heterogeneous behavior. And in particular, we failed to reject collective rationality for half the sample, but we strongly reject it for the other half. And this is kind of the sort of more established results. So 2 and 3 are more the work in progress part, but also 1, unfortunately. So the second contribution of this paper is to provide evidence that seems to be more consistent with a cohort effect, not a life cycle effect. And the third, even more preliminary part tries to investigate the causes for this heterogeneity, and we don't have answers yet. Hopefully we will eventually. Okay, so I think in this audience, I can be super quick about the model. So think about, the static model from Bourguignon, Browning, and Chiappori. This is, of course, a simplified version. There are two spouses, 1 and 2. They maximize utility as a weighted average of the two utilities. There are some bargaining weights which are affected by the distribution factors. We use the two tests that have been discussed in BBC 2009. The joint proportionality test and the Z conditional demand test. Okay. How do we do that? We use data that were collected to evaluate Progresa. Progresa is Mexico's conditional cash transfer program. It no longer exists. It's now called Prospera, and it's slightly different. But in 98, 99, the program was just started. So what happened in these years to evaluate the program, a census of households from 506 rural villages from central Mexico was collected. This is kind of interesting because although not representative of the entire population of households eligible for this, these villages are representative of a very large share of the eligible villages. So it's a large sample, but it's also representative of a large and inherently interesting population. What's nice about this? Well, many things are nice about this data, among which that the program was randomized by village, as is well known, so we can exploit this unexpected and large change in income which accrued to the wife in a household as one of the distribution factors. On top of that, there are another couple of nice features of this data, which is, first of all, that it has a very detailed consumption module, so we can have fairly accurate consumption data. And on top of that, we have large information on the socioeconomic characteristics of the households. And again, I think what is nice is that this is a relatively homogeneous setting. So these villages all rely on subsistence agriculture. There are a couple of crops that are cultivated in all of them. It's, I think, corn and beans. There is a very limited amount of migration. Most people are poor. Well, in fact, everybody's poor to different extents, and most people are like low educated. Typically, the husband is the main earner in a household. And again, typically, the main source of income in the household is from the husband's supply of daily rural work. There are no formal financial markets, although there are informal ones. These are very small villages. I think the median village is about 50 households, and there's a high degree of connectedness. So they're sort of all relatives to each other. So they're all related to each other. OK. As I was mentioning before, and as it's been extensively done in the literature, we exploit the eligibility for Progresa as one of the distribution factors. So let me remind you again, this is a large income shock. It's on average about 25% of the household's counterfactual income. It is given to women. It was unexpected. This was the very first time that, well, with the exception of a small, a similar program that was implemented at a small scale in Brazil, this was the first time that a large-scale CCT was done. So it's kind of a common anti-poverty program now, but it was not at the time. So it's plausible to presume that it was completely unexpected from the household's perspective. And there is some indirect evidence that the receipt or the entitlement to this transfer does not affect preferences, which is, of course, important for the validity of this as a distribution factor, and also direct evidence that the entitlement to this program did not impact labor supply. Now, as you're all aware of, this is a conditional cash transfer program. So let me discuss here why that matters and how we deal with that. So the bulk of the Progresa transfer is in the form of a scholarship, so a school subsidy that is awarded ex post. So the child goes to school for at least 85% of the classes for 2 months, after which, upon verification of compliance with this, the household receives a large part of the transfer. There is a small component of the transfer that is purely unconditional, but this is like a smaller part. Now, formally, the bulk of the transfer is conditional. In practice, most of the transfer is de facto unconditional because out of the years that are subsidized, this is from grade 3 to 9, I think, enrollment is virtually 100% in the counterfactual villages for primary school. So for kids in 3rd, 4th, 5th, and 6th grades, basically, the kids would have gone to school regardless of the program. So we can think of those kids as receiving an unconditional transfer. Conversely, for kids in secondary, middle school, so in grades 7, 8, and 9, the attendance rate is much lower. It's about 2/3 in the counterfactual villages. And so now for some of these households, the conditionality binds. So they have to change their behavior, their time allocation, and everything else to be eligible for this program. And so there are different ways of dealing with that. What we do, so in the data that we're going to show you, we drop the households that either have kids within an age, so in the relevant age interval for being enrolled in middle school, so basically kids aged 11 and older. Alternatively, and we show you those data only, alternatively, we include a narrower, so we have a broader definition. So we exclude kids who not only are within the right age interval, but also within the right grade interval. So there's a lot of grade repetition in this environment. So not all 11-year-old kids are enrolled in 6th grades. And so we look at baseline kids who might be in the treated years potentially affected by the conditionality. Okay, so basically we exclude kids who are in 6th grade in the year, or 6th and 5th grade at baseline, who might potentially start 6th grade at one of the point in time of the 2 years that we observe. The robustness checks, we do yet another exercise. I will talk about it later, because then we try to replicate what Attanasio and Lechen do. So as Jeremy, I don't know where anyways, as Jeremy was mentioning, so there's a well-known paper where Attanasio and Lechen do a similar exercise for the entire sample without splitting it. And so I'll talk about it then. Okay, so that's number one. So it's kind of, it's no longer kind of the new thing to do. I think this is now well established in the literature, but I just wanted to carefully mention that anyways. And the second distribution factor is even more well established in the literature. We use the female ratio at the municipality level. So remember, Mexico, a bunch of villages grouped in municipality, which is the kind of the medium size administrative unit, and then there are states, and then there's a federation. So we looked at municipality level sex ratio in 1995. So this is the most recent year that we could find. So remember, the data we have are 98, 99. Now, little digression. So these villages that we're looking at are very poor, as I will show you. So migration is very low. Nevertheless, Mexican migration tends to be more male than female oriented. Therefore, again, as I will show you, the female ratio is actually correlated with the local wealth and migration level. Okay, so we have to be careful about using that as a distribution factor, and I will talk about that.
Municipality is the relevant marriage market?
I'm sorry?
Municipality is the relevant
It is, because there's very little migration. So people kind of are born and live in the village, the typical person.
That's what I'm saying.
Yes, it is. It is the village, the marriage market.
One doesn't fall from the other, right? In India, there's very little migration, but there's a lot of...
Well, I define that migration. Well, it depends on what you call migration. Yeah, there's not a lot of marriage. There is some marriage migration in Mexico, but it's more kind of within the municipality. So typically what happens is that the woman marries into the husband's family, pretty much like in India, so she moves into husband's family, but these are mainly local moves. So we don't have as detailed information about geographic mobility, but we have some information, and that's consistent with this idea that people are kind of born and raised in their own little corner of the world.
Two things. First of all, the eligibility for Progressa. You can think of it as a discrete, you're eligible or you're not, or something.
And discrete what, sorry?
It could be discrete, like either you are or you're not. Or you could think of a continuous version,
yes,
which is if you're conditional on being eligible, it might represent the fraction of total income that it represents. I don't know which one. And the second question is, Attanasio and Lechen, they are using also as a distribution factor the size of the network.
Yes.
Did you look into that? Or?
Yes. Well, yeah. So they sort of were inspired by the research that my co-authors and I did using that. So yes, we are familiar with that.
Going to use
I will talk about it, no, for reasons that are varied, and perhaps, do you want to know about it now, or?
No, you're going to talk about this.
Yeah, let me talk about it whenever I had planned on. Okay, but so the main distribution factors that I'm going to deal with now are these ones. And it's true that there are different ways of using that. So more akin to what has been done in the literature, we could also use the income ratio, the spousal income ratio. We do that later. So I will show you that, in the more tentative parts. Well, but let me explain it now, because I think it's relevant. So basically, we sort of do it when we don't have any other option. The idea being that in the counterfactual village, the median woman earns 0, right? So basically, all the variation is given by Progressa, and this variation is not exogenous, because if you have a larger family or more kids who are going to school, then you're entitled to a larger cash transfer. So one could argue that, hey, the variation of so basically the numerator of the wife income is strongly related to the household socioeconomic characteristics and demographics, and so one could argue that then it's less clean because it might be related to preferences or other things that we haven't fully controlled for. So that's why we're saying we lose variation, of course, by using a dummy variable as a distribution factor, but in a way it's kind of cleaner because it's relying on this randomization, right? So there are pros and cons. Okay, so I talked about the distribution factors. Expenditures. Okay, so there's a really cool consumption module. So there are 36 food items on a 7-day recall. So it's quite detailed and with relatively low level of recall error. We aggregate these categories, of course, in many different ways. So the way that I'm going to report here is, I think, 7 different categories. Dairy, fats are just like butter, oil, and lard. So it's stuff used for cooking primarily, not for direct consumption. Fruit, meat, starch. Fruit and meat is kind of self-explanatory. Starch is a bit arbitrary because it's related to macronutrients. So like potatoes and some pulses or large, or bananas are large provisions of starch, but then banana is a fruit. So we just try different things. Sugar is junk food. Basically, it's stuff that is considered very unhealthy for you, so snacks and these kind of things with hardly any, for example, vitamins. And vegetables is also self-explanatory. And as I said, this is all from a 7-day recall. In the end, we just create monthly consumption expenditures for everything. The known foods categories. Again, we aggregate in somewhat arbitrary fashion. So we have child clothing, female clothing, and household general goods. In the results that I'm going to show you, we put these 2 categories together because we argue that these are the things that pertain to women's domain. Then we have health expenditure, male clothing, and smoking, which we also lump together, and then school and utilities. Now, these have a different time horizon, so which ranges from 1 and 6 months. And again, we convert everything into monthly consumption expenditure. Oh, another important factor. We have unit values for foods and information on prices for non-foods. And this is going to be important for the way that we estimate the angle curves. Okay, covariates. We control for households, age, for the age, the education, the literacy, the indigenous status of the household heads. Also for detailed information on the composition of the household, also because it's important for the amount of transfer that a woman is entitled to. And this is important because it's related to how we interpret the sex ratio distribution factor. We control for the village marginality index and the migration share. So the migration share is self-explanatory. This village marginality index is an index that is computed by Mexican officials of some sort. It's a combination of 2 different factors. It's socioeconomic marginalization and geographic marginalization, which of course are positively correlated because more geographically isolated villages, everything else equal, tend to be poorer. But it's a composite of these 2 things. Again, the idea is that it wants to capture this kind of 2-dimensional object, which is migration and wealth, which is in and of itself related to the local sex ratio.
Migration share is an outcome variable.
Yes, so we have estimations with and without that. It doesn't really change much. So you think we shouldn't have it and just, I'm not sure.
I would be very hesitant.
Okay, so maybe we shouldn't present it in the main results.
No.
Okay. Okay, so now remember that the whole premise was to say, hey, we find that some households behavior is consistent with collective rationality and others isn't. The question is, how do you form these 2 subgroups in a sample that is homogeneous? So what we used is knowledge of the local behavior and institutions, specifically previous work that I did that was in particular looking at the effect of progressa on alcohol abuse and aggressive behavior. And in this previous work, it came out that the effect of progressa on these 2 outcomes varies largely by what can be called husband's traditionality. Okay, and it turns out that husbands who are older, less educated, with a larger spousal age gap, tend to behave in a different way in response to progressive vis-a-vis these outcomes than younger, more educated men whose wives are not much younger than they are. And so we took that as a sort of starting point. The other so the main results that I'm going to show you look at the age of the household head, and they split it around the median. The other nice feature of that is that we can have two samples of the same size. So the differences are not driven by large differences in sample sizes. And then I'll talk more about the sort of theoretical backgrounds for this when I'll comment on the results. Okay, so for now I'm going to show you, as I said, I'm going to estimate the collective rationality model for households with a head below or above the median age in the sample. Okay, so let me show you some data. These are the main conditioning variables that we have and the distribution factors. So, and these are the older than median headed households, and these are the other ones. Not surprisingly, in the older households, husbands are older, but also more likely to speak an indigenous language primarily, less likely to be illiterate, and with a larger spousal age gap.
Wouldn't the older households still get less progressive by construction because their kids are already out of the household?
Not really. So yes, your answer is, so the second part of your comment is true. So older households on average have older kids and fewer very young kids, but actually in the middle, there's no difference in the age. So the main difference is in the kids' age is at the tails. Okay, so remember that this Progressa gives you scholarships for grades 3 to 9. So for kids who are on average aged 9 to 15, 16. Okay, and there are very large differences in those. In fact, I should have reported it here. Overall, the household size is pretty much the same across these two groups. The main differences, again, are in the tails of the age distribution, as expected. So this is just to show you, as I told you, that migration rates are very low. This is all forms of migration. So labor migration, marriage migration, and migration to study elsewhere. The marginalization index is pretty much the same across these two groups, as well as the two distribution factors. Okay, and this is just the third column is just showing you the difference between the first and the second one. All right, so these are income and expenditure, and then the budget shares. So this table is kind of interesting because it shows you that despite having large differences, both in age but also in some other socioeconomic factors, the wealth of these households, their consumption expenditure, doesn't really differ. And no, I think this is pretty much compelling, showing how poor these households are. So pretty much all their money is spent on foods. And also, I think what's interesting from this table is showing you that although there are some differences in the budget shares for older and younger headed households, it's pretty much sort of the same picture. So there aren't any dramatic differences in the budget shares, right? Even the ones that are statistically different from each other, they're not like economically different at all, or not much. Okay. So this other table, which might be perhaps a little hard to read or very dense, so it's doing the following things. It's comparing the difference between the treatments and the control villages in all these variables that I've just described for old and young households. Okay, so it's basically showing the treatment effects for these two groups. Again, it's pretty much similar. So expenditure goes up, and the sort of behavioral impacts of becoming eligible for Progressa is pretty much the same for older and younger households, which this is all well known and well documented in the literature. So the only thing that I'm showing in addition is that it doesn't vary systematically across these two subgroups of the household. So as is well known, there's an increase in the consumption of meat and fruit and a reduction in the consumption of kind of less high quality foods. And some changes also in non-foods in the non-food budget shares. So these are columns 1 and 2. Columns 3 and 4 are simply showing the partial correlation, so the coefficients of regressing each of these variables on the female ratio, just to give you a sense of how these things are correlated. And I think this highlights this fact that female ratio is correlated with wealth, right? So areas with a higher female ratio are areas with more migration, and so people are richer, they have higher expenditure, and therefore a lower budget share spent on food. And you can see pretty much a constant picture if you just look at all of these. So I once described them one by one. And again, this is why we think it's important to condition on this village poverty index to net out this wealth compound. Okay, so as I told you, we're presenting 2 tests, the joint proportionality one, and the Z conditional demand one. So this is the budget share. So this is the Engel curve, which is a function of consumption and prices and other socioeconomic proxies for preferences. And these are the 2 distribution factors. The progressa dummy, 1 or 0, depending on whether it's in the treatment or the control village, which is randomly assigned, and then the female ratio at the municipality level in 1995. Now, this is the joint proportionality test. Okay, so under collective rationality, this equality should hold. A bunch of well-known estimation issues.
So progress is not just a distribution factor, though.
Yeah, but we're conditioning on household expenditure. Yes.
Which is endogenous, so you control.
So we're instruments. So these are all the estimation issues. So first issue, potential log linearities and potential nonlinearities in log expenditure. So we try both a first and a second order polynomial in log consumption. So consumption is endogenous. It's measured with error. It's also non-classical. It's kind of a mess. Evidence from Orazio and co-authors shows that actually in this setting, using a control function approach with, among other instruments, income seems to do a good job here. So this is what we do. Again, if there's interesting, I can talk more about the details. But we pretty much follow the literature here. So we cluster the standard errors at the village level. We have 506 clusters. And we estimate a system of equation. Now, we don't observe prices, as I said. So we do a couple of things. So we have state by wave fixed effect to proxy for prices that vary locally and over time. In some specifications, we add those as fixed effects, so just as parallel shifters. In other versions, we also multiply them so we interact them with expenditures, so that we have prices affecting both the intercepts and the slope of the Engel curve. I don't remember which ones I am presenting. I'm presenting just a set of the many different robustness checks, and then discuss the others, as you will see in a minute. Anything else about this that I need to discuss? I don't think so. These are the main estimation issues in this literature, and we sort of deal with them following the other papers that look at progressa as a distribution factor. Okay, so that was the first one. Then we have the Z conditional demand. So we invert on the female ratio, which is the continuous distribution factor, and then we have this regression here, and we will use utilities as the demand that we invert on. Under collective rationality, then this coefficient should be 0. So that's the other testable implication from this model. What else is there here? Well, then the inverted demand is correlated. So the utilities demand that we add on the right-hand side here is correlated with the error term. So as usual, we use the instruments that we inverted on the female ratio as, the distribution factor that we inverted on the female ratio as an instrument for this. This whole setting is based on the assumption that the DJ is monotonic in sex ratio. So we test for that, seeing whether a quadratic is significant or not. And we find that it's not. Okay. Yeah, so that's pretty much it. So let me just show you the results. Okay, you won't be able to look at it, but these are, so let me just tell you what they are. So these are each of the Engel curves, right? Food is up to here, and then this is the non-food one. So we have a system of, I think there are 13 different equations, and then we estimate them separately for the younger headed households and the older headed households. If you just want to look at some numbers, these are the high test statistics for the giant significance of the distribution factors. So a few of them, not all of them, but a few of them are significant. In most cases, I think both factors are either jointly significant or not, neither statistically significant in the angle curve. Okay, let me just show you something that is more seeable. So what we do in this table is that we present the results for the entire sample first, and then splitting around the median age of the heads. So we have the young and the older-headed households. So here we're just testing for the joint significance of all the distribution factors, which is also indirectly a test of the unitary model, and we reject this null hypothesis, not surprisingly, as everybody else has done in this setting. We also reject for the subsamples. Okay. These are the joint proportionality tests. So reject for the whole sample. We reject for the young. We do not reject for the old. These tests are not very high powered. There are no linearities, so some people caution against weighing too much on them. So we also present the z-conditional demand tests. Again, we reject for the whole sample. We reject for the young. We fail to reject for the old. And this, forget about this. So basically, so far I've showed you that, well, I think a couple of interesting results. The first one is that unlike Bobonis and unlike Attanasio and Lechen, we actually reject also for the entire sample. So I want to talk about that for a second. But before that, sort of the main results that we propose, or the kind of new thing, is that when we look across the sample, we find heterogeneity. Okay? In particular, we find that younger-headed households do not behave in a way that is consistent with collective rationality, unlike the older guys who do.
Just reject for young and not for...
We cannot reject for the old.
The title says the opposite, so... It's...
Yeah. So we reject the null hypothesis, which means that they're inefficient. Right? Yeah, always.
So you can reject efficiency.
So the young guys are inefficient. Right, so we reject the null of collective rationality.
The title says
you not reject efficiency.
You're saying that...
Yes, yeah. We cannot reject collective rationality for the younger ones.
So
you do. You reject for the young.
I'm sorry, yes. Yeah, I always mix it up, yes. So this is wrong. So we reject collective rationality for the young. We reject the joint proportionality and the z-conditional demand tests, but not for the old. Yes, sorry about that. Okay.
Sorry, so you said for the overall sample, why do you think you find different results than these?
Okay. So basically, let me start from the end, and then the punchline is that we can replicate Attanasio and Lechen. So when we use their data differs, or the use of the data differs from ours in 3 dimensions. First, or 4, I don't know. Anyways, let me just tell you. So first, they only focus on food. Okay, so they assume that the choices between how to allocate a budget between food and food are fully separable, and then the nice feature of that is then they have unit values, so they use those to have prices. So they estimate a full weights model, not ours, in which we have this dummies interacted or not. So we do that too. The second difference is that they use 2 and not 3 data weights, so only the first 2 and not the third ones for those who are into the intricate details of this data. The other difference is the use of distribution factors. So they use the treatment's eligibility dummy as we do, but they also use this, 2 versions of distribution factors that are related that are based on the fact that households are related within these villages. One is the ratio, so this is kind of some lack of clarity in their paper, at least as far as I know. So they say that they use the spousal ratio of siblings and cousins. So in these data sets, we observe people's last names, and given that in Mexico people have 2 last names, one from the dad and one from the mom, we can sort, under some assumptions, reconstruct the degree 1 links. So we can identify the parents, the siblings, and the offspring of a given household heads and the spouse. So first, and then that's what, like my co-authors and I do in a number of papers. So Attanasio and Valerie, they say they do the same, but then sometimes they say that they use siblings and cousins, but then in the equations, they actually show it also for only for siblings. So that's one of the things that we're not really sure exactly what they did. When we try with siblings only, we find that it's not a very good, strongly significant distribution factor. The other problem with that use of distribution factor is that actually it has mainly 3 points of support. So for 80% of the households, they either have 0 in this ratio or a half or 1. So 0 means that they don't have siblings. So when neither has a sibling, they just assume the 0. A half means that one has more, like I have 2 siblings and my spouse has 1, and 1 means that we have the same number. So there isn't a lot of variation, unlike in the female ratio that has much more variation, although it is, it's in a limited interval. And then the third difference, or whatever number difference between our approach and our treatment of the data and theirs, is that they're using the entire sample of eligible households, including those with kids who are potentially changing their time allocation to go to school, so the older kids. And what they do, they use they use an IV approach here, using distance from school as an instrument for the schooling decision. So when we do all those things, we actually replicate their findings in the sense that on average, they find that the behavior is collective, it's consistent with collective rationality. So we take this variation, so according to how we cut the data and what distribution factors we use, we find differences. This is pretty much consistent with our story, right? That there's a lot of heterogeneity in the sample. So you cut a little bit here, you cut a little bit there, and then the behavior of the average household changes because you're dropping some some non-random households. In particular, when you keep the entire sample of eligible households, on average, they're slightly older, a little bit. And so as we show, the older guys are the ones more likely to be efficient on average. So basically, we're waiting, this method, I think a punchline from this long digression that I've made is that this method gives more weight to older households who are on average more likely to be efficient. And therefore, you find that on average, households are efficient. Yes, I don't know if this was clear, but again.
Sorry.
Just a quick question. So it's basically not a type of household that is not rational, but you're saying some people become more rational when they get older? Is that
Who knows? No, the first step is that there are differences, right? And now more like, okay, so let's say that you're with me so far, you believe this result. So the young ones are inefficient and the old ones are efficient again on average. Then there are 2 conceptual interpretations that are consistent with this. One is a story of cohorts differences, and so the cohort effects, and one is a story of life cycle effects. And I can give you sort of nice stories that kind of ring a bell, right? In one case, actually, I think I've written them down, so let me just read them. So one can think of efficiency as being kind of an acquired taste or a learned skill. So you have to learn about you, about the partner, and so it might take time, right? So this might be a view consistent with this idea that we would expect life cycle effects in efficient behavior. There's also like another type of story, which is, let's say that there's no learning at all, but some matches are good, some matches are bad, and the bad matches, which are inefficient, disappear over time, and so you just remain with the efficient ones. So this is also a story consistent with finding changes over the life cycle, because some households just disappear, and they happen to be the inefficient ones. But there's also a cohort effect, right? There might be, and we know that this is important, so there might be potentially differences in technology. Imagine, women enter the labor force, or there's change in the supply of saving mechanisms, so the income process for women changes, or the observability of the incomes change, so it's a technology story. But it could also be a story of attitudes, right? So in Italy, for example, where I'm from, divorce used to be like strongly stigmatized a few decades ago, and it's more acceptable now. And Mexico sort of underwent a similar change, with divorce being really stigmatized and therefore not really socially acceptable to becoming more. And this might change the way that the whole marriage is conceived and so on and so forth. So basically, let's investigate, being completely agnostic for now as to the potential sources, whether this is a life cycle and a cohort effect. Now, of course, from a cross-section, it's hard to do. But we have a trick. So we have 2 ways, sort of. Test 1 is the one that, it's not too exciting, to me at least. And the idea is that, so I've shown you young versus old. And now let's group households by characteristics that are time invariant. Okay, so for example, let's look at education, which doesn't really change over time for people who are 18 and older in this environment. and the spousal age gap. So we create an index of these two things, and again, we split the households around the median, and no. Again, we show that for a group we reject, and for the other we do not. So the low tradition guys are efficient. The high tradition, sorry, I always get this wrong. So the low tradition guys are inefficient, and the high tradition ones are. But then again, this is sort of a trick, because this thing is strongly correlated with household head age. So although this difference is visible or also on time invariant characteristics, it might still be a compound of life cycle effects. This is the type of test that I like the most, because it seems to be, to me, cleaner. The idea is that we have, so again, let me start from the end. We have data, so there are data collected from the same villages in 2007. So remember that the data that I discussed so far is 98, 99. And so we have data that are like 8 to 9 years later. And so the idea is that, again, I could tell you more or less. I'll choose to tell you less about this data. They're sampling from the same villages, but they're not really being accurate in sampling the same households. So there is a very small overlap in terms of identifying the same households across these 9 years, but it's the same environment. So what we're doing for now, and we'll be much more sophisticated later on, but we're just taking all this 2007 data. Some of the households we can identify back to 98, 99. A lot of them are new households. And we do two things. One, we again split them around the median. The idea is that now some of the young guys have become old, so they aged into the other group. And so if it is a cohort effect, then we should expect the old guys to be also inefficient. So remember, the young guys were inefficient, now they're old, they're still inefficient. If it is a life cycle effect and people kind of become mature, enlightened, and efficient, then we should expect that the old guys are still efficient. So remember, the new old are the old young. The other thing that we can do, so this is a bit of a mess too, also to describe it, but the other thing that we can do, we basically take the 2007 data and we reweight them based on the distribution of the young in 98, 99. Okay. All right, so this is old stuff that we're just putting up for comparative purposes. So these are results that I've already shown you. And this is the Z-conditional demand tests using the 2007 data. Okay, so what we're doing again is we're splitting around the median age of the households. And now look, now neither group is behaving in a way that is consistent with collective rationality. This is consistent with a cohort effect. So the young guys in 98, some of them have become old and they have brought the inefficiency with them. Second test is to reweight the 2007 data to map the distribution of the young households in 98. Same story, right? Now also the old are inefficient. So basically, this preliminary evidence is consistent with the cohort effect story. So different cohorts behave differently. It's not a learning fact or a life cycle phenomenon. With the caveat that, again, the data, we're looking at households in the same villages, but they're not, only a subset is the same household. And also, we can no longer exploit the treatment dummy as a distribution factor, because by 2007, both the control and treatment villages are treated. And so what we do is we use the spousal income share with all the caveats that I discussed. Right? Which YS with a larger income share means that they're entitled, that they have household demographics such that they're entitled to a larger income. Yes. And so if you're with me so far, I've shown you two things. One is that the young ones are...
One thing that I feel a bit uncomfortable with. So the sex ratio, as you say, the difference in sex ratio is due to differences in migrations, right?
Well, to some extent, not entirely.
Because it's not so clear. I mean, if those people, those villages are isolated, I don't think the number of boys who are born is that different from the number of girls. So it must be migration.
Not entirely. So the fragile fetus hypothesis. I think somebody was mentioning it yesterday.
Well, anyway, now if I suppose young people, you don't migrate when you're 55, you migrate when you're 25. So, if we think that migration is endogenous to some extent, that should not be a problem for the old generation, because essentially it has to do with behavior of young people, which are, but there may be a lot of selection into the young sample, because if the high sex ratio means that those are the villages in which most high quality young men migrated. I mean, I don't know.
No, that's true. Yes. So I see what you're saying. I think this is an important point. On the other hand, it would still, I cannot see how that would explain why we find this heterogeneity in 98, 99, but that no longer in 2007. So this can explain something, but not the entire picture.
The selection that was only among the young people at the beginning is going to prove.
No, but migration is an ongoing phenomenon.
Yeah, but
Right.
still.
So why 98?
Unless they come back, you still have those missing.
So would you be happier? So you're suggesting that we use a different distribution factor?
Yeah, I mean, well, which is the usual question is the distribution factor a distribution factor? I mean, there is.
Well,
it's
yes,
not easy to
a
escape
different variable
that.
as a proxy for a distribution factor. Yeah, no, we can do that. I think we have some candidates in mind, and we sort of go back and forth.
But Manuela, the distribution factor you're using is like in 1995, it's predetermined. It's like something that you observed like many years before. The sex ratio.
The sex ratio, yes,
measured
it's
like many
95,
years
and then we use 2005. So we try to use sort of the contemporaneous one. Because in our mind, we have in mind a sort of dynamic model with limited commitment. So, okay, so how long do I have? Do I have time?
You have 5 minutes.
Okay, that's perfect. So this is what I would really like to have, feedbacks and ideas. So apart from, these concerns or these comments that you've made, so far I've shown you that there are cohort effects and that some groups are, there are cohort effects and that's it. So the next step for us is like, what is causing these differences across cohorts, okay? And so one story could be about technology, for example, right? So this reason for thinking about technology, and in particular asymmetric information, is informed by these papers that I started to mention. So these kind of small samples that use experimental variation. All are variations on a theme of how much information is disclosed between spouses or not, which suggests that the asymmetric information might be an important source of potential inefficiencies. But then we couldn't really pinpoint anything. So financial institutions, first, there are no formal savings. So there's no bank, no sort of supply of formal savings products. And it doesn't change over time. So it's not in 98 and 99, it's not in 2007. So there's nothing there. There's no variation, either cross-sectional or intertemporal. So that doesn't seem to be the thing. We couldn't find any obvious differences in hidden income across cohorts. Okay, so remember the story that women pretty much stay at home and do some small jobs seems to be the same over time across different cohorts. So there's no change of labor supply at either margin for women. There's also like on whether they work in the household or outside the household. So we couldn't find anything that's kind of struck us that as a potential change in technology or on the observability of income of the spouses. I have to admit that we focus most on the wife. So maybe there are some changes in the husband, which we haven't looked at yet, but I would be less expecting them. Another story could be about the match quality. And here we sort of find something but these are like small effects. So it's hard to sort of reconcile that. So for example, the young, surprisingly, that was completely against my priors, marry at a younger age than the old, but it's only 4 months. So yeah, if you say that marrying young is a proxy for having worse quality matches, then sure, it seems to be slightly worse quality matches, but it's 4 months. So how much can you learn with 4 extra months? I don't know. I wouldn't know anyways. We find differences in divorce. This goes in the opposite direction, but it's not surprising, right? So the young divorce, less frequency, but they also have had less time to do that. So what we're going to do now is to calculate kind of the implicit divorce rate per year. Anyways, these are such small numbers that, again, it's hard to rationalize them as the bad matches have been weeded out for the old, just because the numbers are so small. And now we're just thinking, so potential candidate might be simply the way that marriage as an institution is perceived. And here, again, it's very hard to have hard data. Sorry for the linguistic mess. But we have some data on attitudes, and we haven't looked at them yet. So we're hoping that is going to give us an indication of whether different cohorts have like inherently different attitudes towards institutional marriage, which might indirectly inform us on potential inefficiencies in behavior. But it's sort of a loose argument. So I would really like to hear comments or suggestions on like potential things that we could look at to try and understand the mechanisms. Because for now, just one more thing. So for now, to me, like looks like this paper has kind of some interesting facts, but not really pinpointing the potential mechanism. So suppose that I've convinced you so far that there are cohort effects that determine this heterogeneity. What is it about these cohort effects? And I don't know it yet. So
it's not even clear that bad match quality should imply inefficiency.
No, exactly. So even that, who knows? So
why should you, even if my match is not the perfect one, why should we leave money on the table?
Sure, I agree. So far we sort of have a fact without a story. So I was hoping that you guys might suggest.
How large are these? Young and old.
Can you say that again? I'm sorry.
Are the young and old only a couple of years apart?
No, they're not. So the media, I wish I remember numbers.
Yeah.
So there's a big difference.
Oh, it's a big difference.
Yeah. Oh, one of the many things that we do actually, so we also do like various different trimmings. So we trim the tails, for example. So the results are not driven by the tails of this.
Data quality is same for
yes.
all that? Because other things is younger people have less experience how to answer about their household budgets and things like that.
You would expect maybe in the tails, the very young or the very old, but no, these results are they're really, really robust.
Just trying to come up with
No, I wish, yes, I wish that, yeah. So let me just I don't know if I talked about it, so just to review. So different splits, different model specifications, different expenditure categories, different set of controls, different subsets of the data, different covariates, trimming the tail. So all the results are robust to all that. So to me, it doesn't look like it's some sort of statistical fluke. There is something there, and it seems to be, so far, it seems to be a cohort effect, but no.
Manuela, sorry, I may have asked you this already in the past, but do you actually find some kind of a gradient when you change the way you distinguish between young and old?
We could do that. We haven't done that. So we just took the median because we wanted to have two samples of approximately the same size. We could cut at different thresholds. There's no reason why not. But do you have in mind something?
No, I'm just wondering because, this trimming is somewhat arbitrary.
Yeah, it's completely arbitrary.
Things, but, if you find some kind of a gradient, maybe it can suggest you something about possible causes. It's not clear to me which ones.
Mm-hmm.
Maybe it's non-linear.
So basically,
Do you use all the households have kids in your sample?
No, I exclude different subset of households. First, I exclude all households with kids who are between 11 and 16. Then I exclude only the subset of those who might be potentially in grades for which the conditionality binds. And then I use the entire sample, as Atanasio Leschendo, using distance from secondary school as an instrument for secondary schooling.
But have
Still
you
same
used the
story.
sample without kids as a falsification test for the younger?
Well, the sample without kids doesn't receive Progressa money, right? So I don't have a...
So that's an interesting test to look at.
But a test of what? Because then I have just one potential distribution factor.
So you could actually estimate it as if they were...
I mean, I could certainly do that. Yeah.
To see if it's something else.
But what would I'm not sure what I would expect to find that the treatment dummy is not, does not change the angle curve.
I don't know, in a dynamic context, young childless people will have kids.
Oh, because you're anticipating that you're going to have a future income. That's true, yeah. But then, anyways, sure. No, it's certainly something that I can do. Was Clement? Was there another? Okay, thank you very much.